I explained how to create a basic draw command using Regal. And so now we're going to dive a little bit more into some of the details of how you work with these. So if I take my dev tools here and resize them, you'll see that the canvas doesn't redraw. It doesn't reflect the changes we've done. So in order to do that, we need to create this draw call in a loop. So Regal knows that you're probably going to want to do this and provides a handy mechanism to access the request to animation frame loop and let you hook into it. So here you can see now whenever I resize, it's going to redraw the screen because it's clearing every time. And some of these calls are dynamic. So for instance, if I do math.random times 0.05, it will kind of flash on the screen. So there will be a flash here in a second. Maybe I didn't do it bright enough to, yeah, there you go. And since compression might be bad on YouTube, let me make it flash a little bit more. You can see these values can dynamically take it in. And at this point, if you care about performance, you might be thinking, oh my goodness, you're allocating an array here and an object to tell Clear what to do. You can hoist that allocation outside of it, but in my practical experience using Regal and doing performance profiling, these small allocations really, I don't see them affecting performance, and I don't see GC issues from it. So I wouldn't worry too much about inlining these. You can do the extra work to not have those allocations, but unless it's super complicated, I would just make it easier to type. And so now I'm doing this in a loop, and I can start to play around with values and change them over time. So speaking of time, we have no way to change this. And so I'm going to create a uniform value. So uniforms. And then my time I'm going to set to a function. Actually, I'll just set to a value first. We'll set it to 0. And then I'm going to pull in that into, let's do it in the vertex shader. So I'll do uniform float time. So now if I do vec2 of position 2 and set it to the position, and then I can do position 2 plus equals time. I can start adding, or position 2 dot y, add the time to it, and then set that to the final value. I can start modifying the height. Unexpected token. I always forget those commas. So now I can affect the height of the triangle I've created using time. So I'm going to go back down here to time and change these values. And that was way too much. So 0.1, 0.2, 0.3. It's going off the screen, so we'll go back in the other direction. Negative 0.345. Okay. Yes, if you've done WebGL, you've seen uniforms before. But maybe what we want to do is provide a function here to update these with our own code. So I'm going to go ahead and take time, and I'll do date.now times or divided by 10,000. And so I have this callback expression, this arrow function, that is going to run and change things over time. Oh, so not date.now. This is hard. Let's do date.now modulo 1. Let's see if that does anything. Okay, it's going slowly up now. Great. I've magicked my way into a solution. Make it go faster and faster. Now, as you might expect, you need time quite frequently whenever you're working on a shader. And so rather than having to figure out how to do the time since you first started the visualization, Regal provides a context that gives you lots of useful information. So let's go ahead and drop a debugger in here. debugger statement. And let's go over here and inspect what's going on. So we see context. I'm going to pop over to console and type context. You see I have an object, drawing buffer height, width, pixel ratio, tick, and time, and viewport width and height. These are like really common things that you usually want, and Regal provides these by default for you, which is really nice. And in addition to that, you can add your own items to the context. So you could add like, where's the global light value? Where's the some global transform that you care about? Where's the global camera for the scene? So the context is a really handy place where before with something like Three.js you'd think in terms of a scene graph. Here you think in terms of using a context and additionally props, which I'll get into later. Okay, so we've seen that. Now pop open my console again. So when I type things, I get bad information. I get my logs rather. So I'm going to go ahead and take context.time and feed that in. To have an error, so let's see what I did. I go ahead and oh, it's running in a loop. That's why. So I didn't return the value. That's silly. Okay, so now we're seeing that we are returning the time here, and it's just zooming right off the screen. And so using kind of more of the ES6 syntax, what's really convenient is to destructure that time out and pass it right through. So that's the style I typically use, and I'll go ahead and do that modulo trick I was doing earlier. Do mod 1, so you can see it pop in and off the screen. So like this is just showing that you can pass values in, and any value that you see here, I believe you can take a function and dynamically compute it real time, which is really nice to be able to play around with values and pass things in from JavaScript. It handles all the bindings for you, and it gets you into your script, and you start programming things right away. And then I'm not going to go over varying values because I'm not going to talk too much about WebGL, but with attributes and uniforms, you have most of what you care about for basic WebGL support. So that's it for this video. On the next one, we're gonna take the bunny rabbit in and render a 3D model and start looking at that.